All right, baby. Time to do some experiments. Time to do some experiments. Let's get a little more water in that one over there on the right. Try to even it up here a bit. It looks like I need a little bit more color in there, I think. Let's just see. How you doing there, Kion? Hello there, Welpsy. What's happening? I think we need a little more color. A little more universal indicator. So I'm adding universal indicator. Universal indicator, also known as rainbow indicator, changes color depending upon pH or how acidic or basic something is. There we go. That's beautiful. Let's start adding acid or base. Right now the pH is pretty low. We can tell that from our indicator scale here. Yeah, it's looking like orange or red. That's low pH, pH of like 3 or 4. Might add a couple drops of base over here. Let's see what happens. You see that violet color grow in as the base works its way through the solution, and when it hits the bottom, it looks like things are turning green. If it's green, that's neutral, so I've neutralized the acid. So that's just a bit more. I'm going to turn this up just a bit more so we get a nice vortex going. There we go. Let's do the same over here on the left. I'm going to add a couple drops of base. Oh, that's pretty. Real pretty. Let's get this going over here. Really turn this up. Just starting to get a little vortex over here. Look at that, gorgeous. Man, that's a gorgeous vortex. Let's try it over here on the left. So you can see over on the right, I've neutralized the acid. You can tell that because it's green. pH of 7 is going to show a green color. Hello there, Lucas, with the indicator system I'm using. They're both neutral. I'm going to go ahead and add a drop of acid to the right and a drop of base to the left. All right, so here we go. 1 drop of acid over here on the right, 1 drop of base over here on the left, and let's see what differences we see. Better add a few more drops of acid, just a few more. Looks like my acid concentration's a little bit low. Give it a good squirt. So yeah, see over here on the left, when I added base, the pH went from 7 to 8. Over here on the right, it's maybe looking a little bit. How you doing there, Allie? It's looking a little bit more yellow. Thanks, sir, Kion. I appreciate that. How you doing there, Dazed? It looks like my acid is somewhat, hey, Lucas, somewhat dilute. It's all right, Phil. No need to worry. We're just going to have a little bit of fun with science over here. Check out the beauty of it. We're not too worried about what's going on, but yeah, I do like to explain what people are seeing and why you're seeing the color changes. Hello there, Camp. Hello there, Eugene. Thank you there, Moonstar Sisters. That's a really beautiful violet over there on the left. Hey there, Beans. Thank you there, Organic. Let's add a big squirt of acid over here on the left. Oh, that's gorgeous. Come on, that's gorgeous. Thank you there, Connor. Hello there, Jeremy. Is that the black hole? Yep, that's correct. So somebody noticed that the vortex sizes are different. This is a really big one. This is a really small one. Here, I'll turn off the stir bars. I'll turn them both off. And when I turn them off and they stop spinning, you can see that this one is larger than this one. I want to turn them both to the same speed, about 50% speed. Let's go like 2/3 speed, so about 67% speed. And certainly you can see a difference in the... Hey, thanks there, Camp. I appreciate it. Thanks. You can see a difference in the sizes of the vortices just based on the size of the stir bar. They're both at the same speed. All right, let's add a shot of acid over here on the left. Oh, excuse me, that's base. It sure is. Of course it's base, man. I mean, you know, the pH went way up to 10. I added the wrong stuff. I'm not drinking a Mocha Run. Not going to happen. One of the dyes is a laxative. That would end the live in about 15 minutes if I drank these. Not doing it. Man, yeah, my acid system is not very concentrated. You can tell I'm having to add a whole bunch of it over here on the left to get some color changes. Let's add a little bit of base over here on the right. Look at that gorgeous pattern that shows up. Left hand, what we are looking at. Look at that rainbow. That's what we're looking at, baby. Come on now, that was cool. What we're looking at is two systems. They both have water. They both have universal indicator added to it. Christopher, you can drink it if you want, but it's going to ruin your evening. What's going on, Tunner? So yeah, they both have universal indicator. Universal indicator changes color depending upon pH or how acidic or basic something is. So if you keep track of this right here, you can see if I add, here we go, we're going to add base on this side over here on the right. And of course, it was somewhat neutral. And as I add the base to it, it's going to go to higher pH. Over here on the left, thank you there, Benny. Over here on the left, I'm going to add a big shot of acid. And when that happens, you can see that the color goes from a green to a yellow. So the pH is dropped. I'll add another shot of acid over here on the left. There we go. What if it's 100? Buck fever, we're going to try it over here, all right? We're going to try it over here on the right. I'm going to try to turn the speed up to 100. Right here, I'm doing it. Looks like a weather map. Thank you there, left hand. Usually the stir bar gets knocked out of orbit when I get it going too fast. We're going to try it, though. And Bucksy, what we are doing is adding either acid or base to a color system that changes color depending upon pH. That's what we're doing. Hey there, Lolbit. They're swirling because there's a little magnetic stir bar in here that's on this machine that, in a sense, is like a magnetic fan. And as the fan spins, it spins a little magnet. Is that? Oh boy, you're testing me. Is that France? No, that ain't France. That's it looked like. No, that's Italy. That's Italy. Thank you there, Dazed. All right, let's add some acid over here on the right. Big shot. Watch what happens. The magnetic stir is about $40. Big shot of base over here on the left. What is CO5? I don't know. Thank you there, Kai the Guy. What's going on, Ava? Thank you there, left-hand bandit. Looks like they're both neutral. So let's add a drop of base to the left. See what happens. Let's add a squirt of acid to the right and see what happens. How do you make it bigger? With a bigger stir bar and a faster stir speed. Make it green and purple. Random. Random wanting the Joker colors. Here we go. We're going to go Joker colors here. I'm going to add a bunch of base to get the pH to go to 10, which is going to be violet. There's your Joker colors, just like that, man. Thank you there, Steve. Thank you there, Kai. Yeah, you know, if you got a color pattern you want to see, just let me know. I take requests. Sharky, what this is, thank you there, Trish. Dazed, I've not made bromine, but I've experimented with bromine. Red and blue, you got it, Jules. We're going to try this, man. Okay, red and blue. That's right, you can do this with red cabbage. Okay, we're going to try red and blue. Blue is really tough to get. I'm going to give it a shot, though, here. All right, red is easy, man. You just got to make the pH really low. So I'm going to squirt a bunch in here. All right, so we got our red over there on the left. And now I'm going to just start adding drops of acid over here on the right. You can see me adding up here at the top. The acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. The only difference is this stuff is like 100 times as concentrated. I'm adding drops, and see, we're at a real high pH, and as I add drops, the pH should drop. We're trying to get to red and blue. We might be seeing some change there. Let me just wait a second. You can see some of the color swirling in there. Oh, there's some cyan at the bottom. Someone was asking for some cyan color. The spinning magnets are called a magnetic stir plate, and the little stirring thing inside is called a magnetic stir bar. I think I got your red and blue there, man. I think I got your red and blue. Thank you there, Random. I can't do pink. I'm sorry about that. I can't do pink. Green wants Manol. Oh, you got it. I apologize if I'm not saying your name right. Thank you there, Sharky. Appreciate it. We're going for green, baby. Come on now. Let's get some green. All right. I'm going to go for the red one. All right. So I'm going to add drops of base. Notice we're at a really low pH. Watch what happens. when I add 2 drops of base. There's 1. There's 2. We were red. Now it's kind of like an orange. We're at pH 4. Thank you there, the editor. We're going to go 2 more drops. 1, 2. Oh, we're like a yellow-green. Thank you there, Jason. Thank you there, Zoe. Appreciate it. Can I make it a gradient of 2 colors? I'm glad you asked. There we go, baby. We got the green. Come on now. Thank you there, the editor. Okay, so somebody once said, let's try to do a 2-tiered system. I think I can do better than that. We're going to go ahead and make this one over here on the left really acidic, okay? So like a colored system. Now what I'm going to do after I've made it very acidic, I'm going to stop the stir bar here. Thank you there, Cameron. I appreciate that. Okay, and now I can't do black. Sorry to the editor. What's going on there, Steve Mazemba? Okay, here we go. I'm going to add a bunch of base here without it stirring. Or is that acid? No, it's acid. What am I doing? All right, here we go. Let's try adding some base here. In goes the base. And let's see what happens. Let's do the same thing over here on the left, but we'll do it in reverse. All right, so I'm going to make it really basic over here. Excuse me, on the right. And I'm going to turn off the speed. And we're going to add a big squirt of acid. And we're just watch what happens. Isn't that gorgeous? Come on, man, that's cool. Tell me that's cool. Look at that. We got like a big, dark cloud in the middle of high pH. And then on the outside, you can see we've got some lower pH. Yeah, I can mix them after it's all done. There we go. Let's get another squirt of acid here. Looks like the acid was neutralized by the base on the right. See if we can get some of the redness to break through the clouds. Come on, baby. Come on, we want to see the light break through that dark purple. Yeah, we'll try getting some cyan a little later. We'll go for it. We all got darkness in our life here and there, but you know what? We all got joy in our lives too. So that's kind of what I'm trying to get over here on this side, you know? It's just kind of showing the joy and grief that's always present in our lives, you know? It's totally true. You know it's true. There's stuff that sucks, but if you stop and pay attention, there's also stuff that's beautiful. God, that's beautiful over here on this side, isn't it? Thank you there, Mark. Really is pretty. Cyan and dark blue. Yeah, we could try doing that. Thank you there, Random. What's going on, iShow? Oh, great. You want to start a new batch from fresh? Yeah, we can do that. We can do that. You want to start a new batch, folks? Let's start a new batch, all right? We're going to start a new batch. So, starting from scratch. So you can see how it's done. Let me get this out of here. I'm going to leave this over here. I'm just kind of liking that. I'm sorry. This is just, I don't know. There's just some beauty there that's just, I don't know, man. I think it's gorgeous. So I guess I'm running the show, so y'all going to have to just humor me. Okay, we're going to do this from scratch here. Okay, and let's see if I can get my magnetic stir bar. I got one here. Where's my magnet to pull it out? Come on, man. People are watching. Come on, man. Where's my stir bar? Crap. Oh, here, I got a really little one. Here we go. I'll get this magnet, okay? So here's one I was working with earlier. Yeah, here's one I was working with earlier. I want to get the stir bar out, so I'm going to use my magnet here. See? Use my magnet to take it out. Up it comes. There we go, and I can pop it in here. Come on, baby. I'll have to take it off with my fingers. All right, let's pop it in there. We'll get it spinning. So you can see how this gets set up. Okay, now I'm going to add some water. This is distilled water, so this is highly purified water, although it's not completely pure. You know, water, if it's perfectly pure, is neutral, which is a pH of 7. So if this water, distilled water is very pure, but it's not completely pure. Here, I'll show you. Again, if it's pure, completely pure water, we would expect the pH to be 7. Oh, maybe. Well, let's just see what happens. So I'm going to add my universal indicator to this flask over here on the right, okay? And the universal indicator is going to tell us what the pH is in that flask. Now, if the flask was clean to begin with, let's see what the result is. Yeah, that's what I usually see. That's usually what I see for distilled water. Distilled water does not have a pH of 7. Distilled water actually has a pH of 6. And that's because when, thank you for the subscription there, Manal, I appreciate that. That's because when carbon dioxide dissolves in water, and there's carbon dioxide in the air, and when that carbon dioxide in the air gets in the water, it makes the water slightly acidic. So that's why any water that's exposed to the air, that's purified, it doesn't have any other gunk in there, it's going to have a pH equal to 6. So we got some yellow. Somebody's asking for orange, so I'm going to do that right now. So I've got a pH of 6. If I want to lower the pH because I want to get to orange, I'm going to add some hydrochloric acid. Add a few drops here. Hydrochloric acid, the same acid that's found in your stomach. Looks like I overshot, didn't I? I sure did. We went right straight to red. Oh, man. It did look a little bit like that, Casimir. Casimirs. Okay, so now we're going to add it. Yeah, we might try adding a few of these together. I added a drop of base. Man, and we went straight from pH 3 to pH 10. My base is really strongly concentrated. Let me add a quick drop of base over here on the left, just to give you something to look at. Okay, I'm going to start adding drops of acid over here on the right. Let's see what happens. Camp King, maybe we'll get to blue. So I'm adding drops of acid to a system that's at pH 10. The acid is going to neutralize the base, so what we should see is the pH start to drop. I'm not doing any mustard gas. Someone just got a tornado warning. I guess that's appropriate with the experiment we're doing. Hello there, Gladys. There's another drop of acid. Isn't that interesting, though, how you see how the acid that I've added, that's like low pH? You can actually see that in the center of the vortex, and it takes time for it to spread out. That actually makes sense if you think about it, because just like the eye of a hurricane has low pressure, the eye of this vortex has low pressure. And when something's in a low pressure region, it tends not to move because things move from high pressure to low pressure, not the other way around. So if something's already in the low pressure center of the vortex, it's going to tend to stay there. So I'm going to add it out to the side here so it'll mix quicker. So there I've added your drop of acid. And it looks like we have lowered the pH from like 9 or 10 to neutral. So I've neutralized the base that was in here. Oh, I'm not doing that, Para. Yeah, we did see a slight rainbow flash, didn't we? Now over here, there's probably more base than there is acid. So I'm going to go ahead and mix this. And if it's equal amounts, it'll be green. But if there's an excess of base, it'll turn violet, which is indeed what I see. So here at Moon Star Sisters, let me show you this. Over here on this side again, I'm going to turn off this, which is infused with base all the way through. The pH is 10. Now what I'm going to do is I'm going to add a bunch of acid to the system after turning off the speed so that it doesn't mix so much. I'm adding it in. And let's see what happens over there. Panda, I could drink it, but the live would end in about, I'm saying 10 to 15 minutes, because one of the dyes in here used to be the main ingredient in X-Lax. Random, if all that was in here was water and the acid and base that I'm adding, if it was neutral, yes, I could drink it, and it would be like salt water. The issue, again, is that one of the dyes that's in here is a laxative. So, you know, go ahead and... Go ahead and drop in the chat the emoji of what would happen in about 10 minutes if I actually drank this stuff. It does look like Gatorade. Okay, the fattest duck is asking what makes it change color. Oh boy. So I usually lose people on this. But let's just do it real simple, okay? There's actually 4 different dyes in here. We're just going to focus on one of them, okay? And one of the dyes is phenolphthalein. It's actually the one that used to be the main ingredient in X-Lax. And you can see it's either colorless or pink. And they add a bunch of different dyes to this to give all the different effects is what they do. Here, let me add just a little bit more acid over here. So while I'm jammering on, we might actually see some cool color changes over here. Oh, look at that going down there. So phenolphthalein, when it's in an acid, acids have a lot of things called protons. And we're gonna imagine this is a proton. It's just a real small chemical entity. And the phenolphthalein molecule, which is going to be represented by my hand, when it's in the presence of an acid, it grabs on to that proton, and it has a ring-shaped structure. And when it's like this, it's colorless. That's what happens when there's a lot of protons around. That happens in an acid. Okay? And for phenolphthalein, it'll be colorless in an acid. When bases come around, bases grab onto these protons and take them away. And when that happens to phenolphthalein, that proton gets taken away, the phenolphthalein molecule goes boop like that. It opens up. And with the change in structure comes a change in color. So as these molecules grab onto protons in acid or let go of the protons in base, there's structural changes, and that causes changes in the color. I'm sorry, I can't do black. I apologize. Para, give me a question and we'll try it. We'll see if I can do your homework here on the live. That'd be fun. Drop some green in the other bottle. So let's get it going green over there. You know, there's a precipitate forming. I can see some little solid chunks. I wonder what those are in there from. I don't really know what that is. But what's interesting, too, is you can see like a pH gradient, right? At the bottom, you can see the red, and then the pH starts to rise. It gets more yellow, and then green, and then aqua, and then the blue, and then the violet. So there's a pH gradient going on in there, which is cool. Yeah, I do okay with chemistry, legendary. I got a PhD in chemistry from the University of Michigan, and I teach it, so yeah. What makes an acid strong or weak? Asks hello. A strong acid is something that, when it dissolves in water, so acids are these things that have these protons, okay? Acids, hey, Mr. Beard, man, come on. Mr. Beard just sent me some money. That is really nice. I appreciate that, man. So nice. Whoa, anyway, acids are these things that have these protons, okay? And what they do is they donate the protons. They give them away. And something that's a strong acid, all the molecules of a strong acid, they all give every single one of their protons away. So none of them have protons. Weak acids, let's say you got like 100 weak acid molecules, maybe 5 of them would give their protons away. So yeah, thank you there, Silver Apples. All right, let's add some acid over here on the left to see if we can get some cool color changes over here. Let's add a big squirt of acid. There we go. See what happens. And we're going to stop this one over here, and we're going to add a big squirt of base and see what happens over here. Come on, baby. Let's see what happens. Oh, look at that. Gorgeous. That is so beautiful. We are really getting this like a blue. Over here is a violet. And then over here, we've got like a pH gradient. Isn't a high pH bad? Not necessarily, Alfred. Like this has a pretty high pH, milk of magnesia. But, you know, if you got an upset stomach, it's actually good. It's all, you know, it's all context related. Whether an acid is good or bad is context related. For example, there's an acid called ascorbic acid. It's responsible for a lot of biological processes in your body. Ascorbic acid is actually better known as vitamin C. Hey, thank you there, Camp King. So yeah, what is 0 in Roman numerals? What a great question. I have no idea. I have no idea. Did the Romans know? Yeah, the Romans probably knew what 0 was. I don't know. I'm not a historian. That is really some goofiness going on over here. Oh, I have hydrochloric acid. Hello? I have hydrochloric acid. Let's add a big squirt of acid over here on the right. Yeah, that's what I'm adding. Hello. I'm adding hydrochloric acid when I add the acid, and I'm adding sodium hydroxide when I add the base. You know what? I lied, folks. Somebody asked if I could make pink. I can make pink. All right, let's add another squirt here over on the right. A little more acid over there. Oh, nice. In Roman numerals, Bryce says 0 doesn't have a numeral. It's just blank. Thank you there, Alexander. Yeah, that's some coolness. Alfred, there could be lakes with high pH, and then if you got in that, it could be bad for your skin. So the issue is, Alfred, not only the pH, but how much of the basic material is in there. So people drink like, you know, you could drink water with a little bit of baking soda added, and that's going to have like a pH of 9 or so. And if there's not a whole lot of baking soda added, it's not gonna do anything. Is there red in the second one? Yeah, you can see some red flecks in there. That's from the acid that I added. Pretty cool, huh? Pretty cool. All right, now what we're going to do Why does the scale stop at 3? So it doesn't stop at 3. The pH scale actually goes lower. You can have negative pH. The issue is this indicator system, pH 3, 2, 1, 0, and all those, they're all red. So 3, this should say 3 and below is red. It should also say 10 and above is going to be basic. Or excuse me, it's going to be violet, sorry. Yes, we're actually making a neutralization reaction. So the actual chemical reaction that's going on that I'm showing you, the base that I'm adding is, here, let's turn this light on so you can see it. The base that I'm adding is sodium hydroxide. That reacts with hydrochloric acid. That's the acid that I'm adding, and they neutralize each other. The acid neutralizes the basic property of the base. The base neutralizes the acidic property of the acid. The H from the acid and the OH from the base combine to make water, H2O. And then the sodium from the base and the chloride from the acid combine to make sodium chloride, which is salt. The lowest measured pH, great question. I don't know what the lowest measured pH ever has been. Somebody Google that for me, man. What's the lowest pH that's ever been recorded? I'm pretty sure it's been done with fluoroantimonic acid. I just don't remember what the pH is. Can I mix the gradient? You got it. We're going to mix this gradient over here on the left. There we go. Get it going. And it looks like it's neutral. We got neutrality over there on the left. We made it spin there for you, Sharon. All right, let's add a big squirt of acid over there. I'm going to have to refill my acid here pretty soon. Where's my, forgive me a second. I've got to find my funnel. There it is. Okay, yep, I can refill my acid. Let me do that here real quick. I'm going to stop this. I'm going to give it a nice squirt of base so there's something for you to watch while I'm trying to reconfigure a little bit of acid over here. Make the purple one spin. You got it. The lowest for water is 3.6. So the lowest pH they've gotten in water is negative 3.6. I imagine that's with sulfuric acid. I would guess they'd get a lower pH than 3.6, but that's, I know, I don't have Google in front of me. Thank you there, David. I appreciate that. I appreciate the subscription. I hope to hear from you. I hope you keep me honest in my videos I make. I make mistakes sometimes, and it's good to have other scientists and chemists in the chat to keep me honest. Because, you know, there's a lot to know, which means there's a lot to screw up. And I do it from time to time. Negative. Oh, I see, Bryce. So you're saying the lowest they found perhaps in nature is mine and waters near Iron Mountain in California. Yeah, very nice. Why so serious? What's going on, Macon? Drop red in the right one. You got it. Here we go. Let's do some acid in the right one. I replenished my my acid supply here. Thank you there too, Rich. Appreciate that. Okay, here we go. Add a couple drops of the acid over here on the right. Now we got some big time concentrated acid going in there. 20% by weight hydrochloric acid on the right. And then over here on the left, I'm going to go ahead and add it in without stirring. See what happens over there. I got you, fattest duck. We just added some acid over there. Thank you there, Raphael. How aren't the tubes melting? Sharon, the acid that I'm adding, first of all, does not react with glass. And second of all, in the water, it's dilute enough that it's not going to do anything anyway. Are indicators always organic? Marika, what a great question. No, there are some acid-base indicators. For example, dichromate. The dichromate ion shifts between yellow and orange depending upon acidity and basicity, and that is not organic. Yeah, Macon, that's why I got gloves on. Both the acid and the base, you know. I mean, it's not like going to happen right away. I've done these experiments without wearing gloves, but it's, you know, if you spill it on it, I just got to get to the sink and rinse it off. It's not like it's going to, you know, burn my hands immediately or anything like that. Turn both of them on. You got it, Dog Day. On it goes. Canada. Yeah, if I left it on there long enough, especially my old skin. I'm using Odyssey. I'm using 20% by weight hydrochloric acid. There we go, Jay. The lowest Hammett value would be negative 20 for a 1-to-1 molar ratio of fluorosulfuric acid and antimony pentafluoride. Thank you there, Jay. The chemist has entered the chat. Found that on Reddit. Someone spilled ammonia on their hands. Legendary did, and it was itchy. Sure. Why are there non-color-based ways to indicate pH? There are non-color-based ways, Patrick. A pH meter will do it for you. So a pH meter will tell you the pH without any color-based system at all. Yeah, watch. I've had that happen too. The pH of fluorantimonic acid is -31. Too rich. Holy cow, that's down there. Yeah, I would guess it would be pretty low. What would happen if I had bleach? You'd probably see a shift of violet pretty quickly, and then that color would fade as the bleach would then oxidize the dyes in here and turn them colorless. We got orange on the right for you, Ramon. Why am I Tommy? Because that's my name. Tommy, Sharon. That's my name. Tommy Technetium. There we go. We got the Joker colors. Too Rich is in the 7th grade. Very nice. Thank you there, Miguel. It ate the shoe. Somebody said, Catherine, you said acids give away protons. What happens with bases? They accept protons. So a really good base is like a proton sucker. It just takes protons out of just about anything. And a really good acid is a really good proton donor. So a base is a proton acceptor, and acid is a proton donor. So they're like chemical opposites of one another. What's going on there, K3? Bases take protons. You got it, Too Rich, Ron. What's up, Steve? Let's add some base over here on the left, and let's add some base over here on the right, just to see what's going on. Come on, baby. Yes, the cyclone is smaller because of the smaller magnet. The size of the magnet matters. Ooh, Jamal, I hope you got that off quick. All right, we want some orange in the left one. How do super bases rip protons off? How do they do that? I think you may have stumped me there. Okay, no, you haven't. Okay, so the way we think about this is a proton is positively charged. And so a base, the way that it chemically exists, it's going to be roughly, fairly negatively charged. And the more negative charge you can get concentrated in a little area, the better that molecule is going to be at pulling a proton off of something else. What makes it spin, Steve? So this little plate here has got a magnetic fan in it. So that's why batteries use sulfuric acid. So batteries use sulfuric acid because there's the sulfate ion in sulfuric acid. And part of the chemical reaction that powers car batteries involves the sulfate ion. So that's part of why they use sulfuric acid. The other part is the protons provide moving charges through the solution of the battery, and you need the moving charges in the battery. What's going on, AFZ? I can try, Sharon. Usually when I make this go really fast, it knocks the stir bar out of orbit. Well, we'll try it. So I'm turning this one way up. What happens to the molecules in a liquid if they get more acidic? Canada. They start to gain a bunch of protons. The more acidic it gets, the more protons they accept. Until there's a certain limit to how many they can grab onto. Somebody had a 12-volt battery pop open. That's pretty good. If I push this much more, I'm at about 80-90% over here. Oh, see, that's what's going to happen. It's going to pop out of orbit. There we go. I'll turn it off. We're going to add a bunch of... No, let's do this. Let's add a bunch of base. And then let's chase it with some acid and see what happens over there on the left. Let's just see. Add a little more. That's some cool goofiness going over there. I wish I had some more factor. All I did, Michael, is I added universal indicator to some water, and then I'm just stirring it around and add an acid or base. Thank you there, Misa K. Okay, let's add some acid over here on the right. A couple drops. A little earlier in the live, I talked about how carbon dioxide is an acid when it is added to water. Someone was thinking about asking the acid, what happened if the acid is corroded to the metal? I apologize, I don't understand the question. Really sorry about that. What are Lewis acids? Jamal, Lewis acids. That's a more general definition of acid. It applies to more substances than the definition I'm using, which is proton donor. A Lewis acid is an electron pair acceptor. And if you define acids that way, you can actually describe more acidic behavior. So it's a little better theory because it covers more things. What's the dark blue acid called? This dark blue substance would be basic, so I'm not going to call that an acid. I may not understand your question, though, Michael. If I full throttle it, usually what happens is the stir bar gets knocked out of orbit. Well, we'll try it over here on the right. I'm going to try to get the stir bar balanced, and then I'm going to start turning it up over here. Here we go. You can see that the vortex starts getting larger as I turn up the speed, and there it gets knocked out. The large stir bars have a really hard time hitting maximum speed. Yeah, I like that. I like now red fastest duck. Yeah, a little America going on there. Yeah, we got the red, the blue, and the white in the background. I'm loving it. I'm loving it. What would a pH neutral poison taste? Would a pH neutral poison taste nice? Sure, there's some poisons that you can't even like smell or taste. There's nothing. Yeah, what's happening here? Thanks for the subscription there, Inez. What's happening is I've added universal indicator to both of these flasks. Universal indicator is a mixture of dyes that change colors depending upon pH, which is just how acidic or basic something is. You're right there, Misa K. It is a little more France in America. It is. Yeah, so, over here it's acidic, pH 3. Over here it's basic, pH 9 or 10. Well, actually, Jamal, technically speaking, carbonic acid, what people call carbonic acid, H2CO3, that has been found in the gas phase, but it has never been detected in water. So because of that, we have to call carbon dioxide itself an acid, because when it goes into water, the CO2 that reacts with water immediately goes to hydronium or proton. If you know what I'm talking about with hydronium, it goes to hydronium and bicarbonate. H2CO3 has not been detected in water. The last I knew. Okay, I'm gonna add some carbon dioxide to this flask over here to show you that it is indeed an acid. Unless I get corrected, unless there's been some recent research of which I am unaware, where people have actually detected carbonic acid in water. I'm not aware of it, but hey, if folks have figured it out, I want to know. I definitely want to know. I thought they'd only found it in the gas phase and not in solution. Anyway, what I'm going to do, we're going to do it right now, Roman. I'm going to add a ton of acid over here on the left, but I'm going to do it this way. All right? Carbon dioxide, baby. Can you see that stuff coming down? That's dry ice. Dry ice is carbon dioxide. Yeah? Let's pop it in here and see what... I can't make it black. I apologize. Okay? What's a hydride? That's going to be like a metal that's combined with the hydride ion. Here we go. See that? This is carbon dioxide. I've told you it's acidic, so this should be able to neutralize the base. Oh, that's dripping over the top. I got a mess to clean up after the live. Look at that, baby. The pH is going down. Come on now. The carbon dioxide, as it bubbles through the solution, it's lowering the pH. So we went from pH 9 or 10, we're down to 8. It looks like we're down to 7. Is that solid, liquid, gas? It is carbon dioxide, solid carbon dioxide, which sublimes. And as it bubbles through the solution, some of it dissolves and acidifies the water. The ice does not melt. Dry ice does not melt, Steve. It goes directly from the solid phase to the gas phase. And now we're all the way down to pH 6. So we took that solid carbon dioxide there, took the pH from pH 10 down to pH 6. Isn't that cool? Uh-oh, I spilled on my little sheet here. That sheet's been alive for like half a year, man. Is carbon dioxide acid in both water and air? Rebecca. I don't know. I don't think so. If you don't mind asking us, if I somehow accidentally drank one of those cups, what would happen? You'd end up on the toilet about 15 minutes later because one of the dyes in there is a really good laxative. Let's go ahead and add a little bit of base over here on the left as it's bubbling through. Here we go. Give it a good shot. So I add a bunch of base, and watch what happens as the carbon dioxide keeps bubbling through, man. Yes, Crisis, that is one of the reasons why soda is acidic. It is a little whirlpool over here. How am I going to get the dry ice out? I'm just going to let it sublime away. What makes it change color? Are there intermediates? Indeed, apathy, there are. So it's a pretty complex system. There are 4 different molecules in the universal indicator, and each of them change color depending upon pH in different ways. These are the different systems. There's thymol blue, there's methyl red, there's bromothymol blue, and there's phenolphthalein. And I've listed the different colors they are at different pH values here. All right? Like at pH 2, you add the red from the thymol blue, the red from the methyl red, the yellow from the bromothymol blue, and the colorless from the phenolphthalein. All together, that looks red. So that's how you get the system. Sorry there, Raven. I'm doing the best I can, man. It's a little tough to talk about chemistry, I guess, when you're just looking at 2 flasks. Yes, I've done I've done many oscillating color reactions, Eric. If you check out my YouTube channel, some of my shorts, and I even have a long form video on it. Can I explain how an acid can also be an oxidizer after the proton is donated? So there are oxidizing acids. A prime example of this would be nitric acid. Nitric acid will oxidize copper. What'll happen there is the nitrogen atom in nitric acid, HNO3, has a pretty high oxidation number. It's way up there, which means it can be reduced quite easy. And if it's reduced, it's going to oxidize things quite easy. And metals are easily oxidized. We did have some Christmas colors, and now all of a sudden, we're at the Joker colors. How would the reaction change if you kept the left flask spinning with the dry ice inside of it? Let's find out. I'll turn it on here. Here we go. Apart from universal... sorry, the comments are coming through a little quick here, folks. Forgive me. What acid dissolves gold? Spider. There's no single acid that dissolves gold, but there is a mixture of acids called aqua regia that dissolves gold. That's a mixture of nitric and hydrochloric acids. Why does it change color, Inez? Because there are different molecules in there that when they gain protons, they change structure, and with the change in structure, there's a change in color, and they gain protons in an acid. They lose protons in a base. Yeah, you can get the gold back to a solid, Zach. Yep, you can get it back out of the dissolved aqua regia. Mercury can dissolve gold. Is that true, Watch? Thank you there, Raven. Is the acid becomes too potent, would the left glass be durable enough not to break? So, Teals, hydrochloric acid, the acid that I'm adding, it does not chemically react with water. And because of that, with glass, with the silicon dioxide in glass. Now, if I was adding hydrofluoric acid, then there'd be an issue because hydrofluoric acid does react with silicon dioxide. Oh, man, we got a flash of the rainbow over there on the right. So, Rebecca, the left one is not changing color as quickly because when you add the carbon dioxide to water, and then I either add acid or base to it, we get a buffered system. And in a buffered system, the pH does not change very dramatically at all. An old form of refining gold from its mineral state. Interesting, Watch. I think I do remember that. I think I do remember this. Thank you for the reminder. Yes, that's correct. What's cool, if you look, you can see all those bubbles in there. You can see a bunch of carbon dioxide bubbles. Watch what happens when I add a bunch of sodium hydroxide base to this, okay? So I'm going to add a bunch of sodium hydroxide base. Look, the bubbles go away. What the heck is that solid thing down in there? What the heck is that? Oh, it's a little solid piece of CO2. I was like, what the heck is that? Do you know how to get to rainbow? I'm going to try, man. I am going to try. Brent, if you figure that out, I want you to make sure to let me know. Okay, check it out now. See how those bubbles, those carbon dioxide bubbles? Watch what happens when I add the sodium hydroxide. The bubbles go away. And that's because the sodium hydroxide, reacts pretty well with the CO2. It's kind of cool, isn't it? I wouldn't, Eric. You can drink it if you want, but one of the dyes is a laxative, so that's up to you, man. It's up to you. The acid's not burning the spinner because it's coated with an acid-resistant plastic. Yes, Jamal, Piranha solution has a lot of sulfuric acid in it. Let's see if we can get the rainbow going here. Come on, baby. Give it to me. Come on. Oh, we just got the two ends of the spectrum. Yes, you can, K-Rod. It wouldn't stay that way indefinitely, but here, we'll do it. We've done it before. I'm going to go ahead. I don't know if this side is going to let me because it's buffered. We're going to try it, though. I'm going to add a bunch of base over here, get a nice blue color. Turn this off. Give it a squirt of acid and see what happens. All right. Let's add a bunch of drops of acid over here so we can get the rainbow over there on the right. Yeah, I'm a chemist, Jessica. Got kind of a weird looking... Look at that. We got red in the middle and violet on the outside. That's pretty impressive to have that because if you've got red in the middle and violet on the outside, that's a difference between pH 3 and 10, which is the difference of 7, which on the pH scale is 10 times 10, 7 times. There's your rainbow, baby. Come on now. So when we saw the red and the violet, there was a difference in acidity of 10 million times. Canepi, I studied chemistry, no chemical engineering. If liquid nitrogen, fruit devour, I wish I had some I could show you. I've done experiments with liquid nitrogen where I pour it on water. There's a long form video, there's a short form video where you can look at, me mixing liquid nitrogen and water together and actually studying, why the cloud forms. There's a huge, beautiful cloud that forms when you do this. And I've looked into that and tried to explain why the cloud forms when you do that. Here we go. Let's add a bunch of these. That's hilarious, Jessica. Oh, man, that's hilarious. Oh, man. Cool action going on. Some cool action. Get turned on over here. That's funny, watch. It is pretty amazing, Stickman. They are absolutely amazing features of nature. Yeah, everybody in the chat, let's see. Why don't you drop in the chat how your week was on a scale from 1 to 10. How was your week? 10 if you loved it and 1 if it was just really rough. Manol, Big 10, Greg, Jamal, 8, Jessica, 1, I love 45. Teals, 10, Sharon, 4, Raven, 2. We're all over the place, man. 8, we're alive. Come on, Zach. I love it. Raven, Lamb Chop, 3, Canepi, 7, Base, 10, Raven, 2. I love it, Dr. Renard. 2, 100. I love full tea. 11, Haley loved it. Somebody got snowed in, man. Yeah, we're all over the place, huh? And there's a 1 or a 2. Folks, those of you who had a rough week, I'm so sorry. I hate that, but I think we all know if we're hanging around long enough that those 1s and 2s are going to change into 8, 9s, and 10s at some point and vice versa. So just hang in there. Better days are coming. And, take it when you got it, I guess. Life is both grief and joy for sure. Grief and joy. Yeah, let's show that over there. I like to do this particular experiment. So, I kind of this particular experiment is my grief joy experiment that we all of us humans, we experience both, man. Sometimes in the same moment. Yeah, that happened to me a little while ago. Grief and joy in the same moment. Here, I'll tell you a story about that. I'll tell you a story of grief and joy that happened to me in the same moment. Here, let me first put a shot of hydrochloric acid in here. So the idea here is that the violet is sort of representing darkness. I mean, it's a beautiful violet, but nevertheless, we're going to imagine this is the darkness of night, and I'm going to give a little squirt of acid in here, which should turn it to red, and that's supposed to represent the daylight breaking through the darkness. And it's a little of both at the same time. And you know what? When you have both, there's a little extra beauty that comes with both colors that doesn't exist with just one or the other. You know? Just try to remember that when you're having a rough day. I know it's easy for me to say, but here's the story of me having a joy and grief at the same time. So my dad, he's been my hero my whole life. And unfortunately, I'm going to call my kid here in a minute. He just called me, so I'm going to call him back. I'm going to tell you a story, and then I'm going to pop off. So, yeah, my dad has dementia, and, that's kind of hard to deal with, and the person that you love and who you've, basically modeled your life after or has profoundly influenced you in your life. They get dementia, man, and that's hard to deal with. And he's the man he was is gone, which is really, really sad to see. And he was such a great dude, just an amazing man. Anyway, Father's Day this year, I'm going to see him, and I don't want to go see him because it's hard. I'm just telling you, it's hard to see. Man, is it hard to see your hero who's not the person they once were. It's no fun, man. So I'm going. I'm like, man, I don't want to do this, and I still go, and I walk in the door, and he looks at me, and he says to me, he gets his big grin on his face, and all he says to me is, I'm smiling because it's you. I'm smiling because it's you. And I'm sitting there thinking, how in the world is it that a person whose brain is almost deteriorated can speak with such, like, poetic, I don't know what to call it. He just spoke with poetry, you know? And it's just an interesting moment. That's all I got to say. And that's it, right? I mean, you got the joy and you got the grief in the same moment. And that's how I felt at that moment, you know? It's exactly how I felt. Thanks there, Jamal. I appreciate that. I appreciate it a lot. So, hey, yeah, I want to talk to my son. He just gave me a call. Sorry there, Raven. Thank you there, Sally. Yeah, I want to talk to my son. He gave me a call. Thank you there, Zach. I appreciate that. Yeah, we'll turn it on. We'll turn it on. I hope these experiments added a little bit of joy and beauty to your life, at least here today. Can't have the good times without the bad times. Hello there, Fortnite. And yeah, we'll, pay attention to the beauty that exists. It's always out there. And thank you so much for hanging out with me and, yeah, just spending some time. Thank you there, Zach. And yeah, I usually do these lives Friday evening. If not, I do them during the weekend. I might do another one this weekend. Who knows? But thank you for hanging out. Thank you for being a part of doing these experiments. And you all have a great night, and we'll talk to you next time. So long.